In this lesson, we're going to start talking about, continue to talk about limits, but we haven't come across any limits that hit an asymptote. So how do we deal with that? What does that look like? So, so the idea is that we're going to probably have to do some visuals. Algebraic is a bit rough, but we can kind of try to do that. In prior lessons, to find a limit, one of the ideas is let's take a look, let's get an idea what kind of graph we got going on, if it's a polynomial, if it's a rational, are there breaks in the graph? And if not, then we just plug in the value and there's our limit. And again, we don't care whether it hits that value, it's what it's approaching, right? And that's kind of the big thing with this as well. So, so the two different kind of situations we can have, well, there's three, but these two are the ones where limits are going to exist. So if we have our function is going to grow arbitrarily large for all x's sufficiently close, but not equal to a. So we're going up and we're going up. Then our limit is going to be approaching infinity because, again, we're all not talking about what value we actually hit. We're talking about what we're approaching. And we're approaching the same infinity on either side. And then the same goes for if we have an asymptote and the graph is going down on both sides. All right, so let's take a peek. So if we have this function, it's the same function. We're going to be looking at the limit as x approaches 1 and as x approaches -1. And again, not coincidentally, those are our domain issues. If you plug 1 in, it makes the denominator 0. But what it doesn't do is it doesn't make the numerator 0. So if you were to plug in, I kind of start with this anyways, is that if I plug in, I get a value over 0. That has a tendency to create an asymptote. What I don't know about the asymptote is, do the graphs head in the same direction or do they go in opposite directions? Like one side goes up and one side goes down. So that's the extra part that I got to kind of dig into. And then for -1, exact same situation, because you're going to have a -1 squared, which is 1 minus 1. So you're going to get a 0 in the denominator and a -1. So again, that screams asymptote, but we need to kind of dig in a little bit deeper. So as of right now, we're just going to graph it. Okay, so we're going to plug it into the calculator, see what the graph looks like, and see what we got. So for y equals, we're going to do x over x squared minus 1 squared. All right, and then we're going to do a standard window. And there's our graph. Okay, so for us, we have an asymptote at -1, which we knew that. We have an asymptote at +1, which we knew that as well. We just didn't know what was happening around it. So we have this happening on the left, and then this going through the origin, and then we have this to the right. Okay, so we have our visual. That's all we need. So if we do the limit as x approaches 1 of this function, x over x squared minus 1 squared, then since we are approaching 1, here's our 1, we are approaching infinity on both of them, our limit is going to exist, and it's going to be infinity. And then the limit as x approaches -1, same function, squared minus 1 squared. And at -1, both sides are heading down, so both sides are heading the same value, and they're both heading negative infinity. All right, so in general, we're going to have a limit that exists if you look at the left side and you look at the right side and they both are approaching the same value. So they're both approaching infinity. The right side's approaching infinity. The left side's approaching infinity. Then our overall limit is infinity. And then same is true if the left side and the right side. So the right side's approaching negative infinity. Left side's approaching negative infinity. Overall limit is negative infinity. When it won't happen is if we have the limit as, remember that just as x approaches a from the left, does not equal the limit as x approaches a from the right. That's when then our overall limit does not exist. This does not exist. Okay, so that's the only time. So basically, if we have an asymptote where one side goes up, one side goes down, that's when it's not going to exist. Okay, so a little bit of digging that we can do. So we'll do one more. So on this one, Again, we need ourselves a visual. If you remember some pre-calc stuff, we have the denominator. If you don't have a factor that's going to match the numerator, then you don't have any holes. So that's going to be an x-intercept. And so let me do a rough sketch. The power on the bottom is bigger than the power on the top. That's like an x to the third on the bottom. So we're going to have a horizontal asymptote. We're going to have an x-intercept at 2. We're going to have a vertical asymptote at 1. We're going to have another vertical asymptote at 3. Right? And then basically, in order to kind of figure this out, we'd have to plug in some values and things like that. So let's finish it off with just throwing them up. So we have an x minus 2 on the top. We have an x minus 1 squared and an x minus 3 on the bottom. All right, so let's see what that graph's going to look like. All right, so here's our x-intercept. It's coming down like that. Left side doing something like that. Right side doing something like that. Okay, so we have our visual. Let's take a look at all the pieces. So we're doing the limit as x approaches 1. So here's our 1. Are they heading in the same direction? Yes. So our limit as x approaches 1 on the left of this function is infinity. The limit as x approaches 1 from the right is also infinity. So our overall limit as x approaches 1 equals infinity. All right, and then this one, we're looking at just the limit as x approaches 3 on the left. So here's 3, 1, 2, 3, and on the left side, we are approaching negative infinity. And then if we approach 3 overall, the right side is going up, the left side is going down. So we have the limits as x approaches 3 on the left not equal to the limit as x approaches 3 on the right, which tells us that our limit does not exist. All right. So that was a quick little idea of kind of creating a visual to help you figure out what's going on around your asymptotes. And if they had the same direction, we're going to have a limit. If they had in opposite directions like they did at 3, then we're not going to have a limit. Limit does not exist. There is another way to kind of do it more algebraically or kind of analytically, and we'll talk about that in the next video.